So we've taken a look at what polynomials look like when we graph them. We talked a little bit about their graphics display and end behavior and whether the end behaviors point in the same direction, opposite direction. We're talking about these highs and lows. And so what we're going to do now is we're going to take a little bit of time and find some polynomials and some other types of equations that correlate or align with some data. And these are called regressions. So the first thing I want you guys to write down in your notes, give me a second, is that a regression is the best possible model / equation function for a set of data. So when you hear that word regression, that's what they're talking about. They're saying, give me a model. And when we say a model in mathematics, we're looking for either an equation or a function. And data might be abstract, or it might relate to maybe a problem or a real world situation. You might want to see, is there any type of patterns here that are worth looking at? And can we use that then to make some predictions? So we're going to talk about how to write a regression and how to compute one. We're going to use some technology for that. And then we're going to do a couple different kinds. But in this example, we want to find a linear one. And since we study polynomials, we know what linear is. That's a first degree polynomial. So here's how we're going to do that. We all have calculators. And we want to take that data. And we have inputs and outputs. So this X column is our input, and the Y column is our output. And then we want to put that data into our calculators. So let me just clear this here. And let me do a couple things. So what we'll do is we will learn how to put that into our calculator, and then we're going to allow our calculator to find a linear polynomial that matches this. So your first button you're going to hit is the stat button. And after you hit that stat button, you're going to hit either number 1 or enter. Okay, this is the window we're going to be looking at. If you don't have these lists, you may have deleted them in the past. You might have stuff in them. Don't use delete. If you need to clear a list, let me just put some numbers in here. But if you need to clear a list, go to the top and select it and hit clear, then enter. Okay? But don't hit delete. If you hit delete, it'll go away. I'll show you an example. Let's say I deleted this one by accident. Pop it in here. Let's try that again. So second delete. There we go. And then we're going to call that list 2. And we'll hit enter. There we go. Okay, so where do we want to put this data? We want to put all the X data in list 1. So just go down here. We're just going to input it, 257. Sorry about that. Got crazy. 2, 5, 7, 11, 12, 16. Our output, or our Y value, is going to go in list 2. Okay, double check that you got the correct numbers in there. I'm going to scan it. We're all good. Okay, so let's clear our key history here for you guys that are keeping notes. Put the data in. You go stat, edit. Now, to find the regression line, you start off the same way. You hit stat, but this time you go over to the window that says calculate. So just use your right arrow to go over to that window, and you're going to find a regression, a bunch of different regressions that you can find. So we want the linear regression. That's going to be this number 4 here. So I'm going to just scroll down to number 4, lin reg, ax plus b. That's the form we want it in. If you have a calculator with a little bit different, it should be similar to this. You just want X list, that's just saying your input. Where is your input? We have our input in list 1, so we can hit enter, enter. We don't need to worry about the rest of the stuff here. We're going to hit calculate, and it's just hitting enter there. And this is good. So this is what we're looking for here. I'm going to show you how to kind of interpret this. I'm going to just grab a screenshot of this. Okay, and I'm going to paste this screenshot right here. So what we're going to do, it wants us to write an equation to the nearest, what does it say? Rounding all data to the nearest thousandth. Okay, that's cool. So here we go. Our equation is going to look like this. It's going to be y equals, I'll underline this, box it in. Y equals ax plus b. Here's our a, here's our b, tenths, hundredths, thousandths. So we're going to look to round this thing right here. 1, 2, 3, and here we go. So our equation, our linear equation is y equals negative 1.024 x, ax plus b. B is 6.047. Here we go. So we're going to practice this idea in this next problem here. We're going to have you find another regression, but we're going to switch up the kind of regression. We're going to call this a regression of powers, a power regression. Okay, same idea. We're going to put the data in. This is going to go in our list 1. This is going to go in our list 2. Once we get that data in there, we're then going to do the regressions. I'll give you a moment to do that. I'll come back to you once I put the data in here and show how it's slightly different. So back at you here, once you get your data in, it should look something like this. Your list 1 is your x values, your list 2 is your y values. And so I'm going to clear this history. I'm going to just show you. Your first step, you hit stat, you go over to calculate. This time, all you're going to do is you're going to look for the one that says power, because that's the type of regression we want for this particular question. Where is it? There it is. Kind of went past a little bit. PWR-REG. We're going to hit enter, go through this again. Hopefully that doesn't change. It shouldn't change. If you don't change it, that'll stay list 1 and list 2. There we go. And again, we'll go to the nearest thousandth, I believe. Let me just grab a screen capture of this. And then let me paste it in here. And then it's just about making that equation fit. Using the right things. Look at the form it comes in, ax and then the power of b. So y equals, here's our a, 615.452, because the next number is a 9, x, and then my power is 1.182. Again, because that number below, after that 5. All we do, find that using our calculator, using technology. Might just review those steps a little bit. The last thing then is once we find that, we're going to then use that to make an estimate. So this is kind of exciting. So we're going to take some data here. This is about crime cases in New York State. And it gives us some information. It says X represents the number of years since 2003. And so that's our input, or list 1. Our list 2 is how many new cases there are. This is the number of crime cases. We're going to round the coefficients to the nearest hundredth, and then we're going to use this equation to estimate the calendar year which the number of new cases would reach 670. Okay, so we want to, you can see this is going down. So 670 is down here somewhat. And we want to know this year. Okay, so if you would take a second, hit pause. Let's put this information into our calculator. We're going to then find a linear regression. So it's going to be y equals ax plus b. Once we write that down, then what we're going to do is we're going to plug in the 670 for y, and then we're going to solve this equation for x. This is our goal here. Okay, so take a moment. Let's find this regression. So I put that information in. I had my calculator do a lin reg, which is a linear regression. And here's my snapshot of it right here. So what I want to do next is I'm just going to write that equation. We want to make sure all the coefficients in the nearest hundredth. So now we're looking at these guys right in between here. So I'm going to write this out like this. So y equals negative 26.51 x plus b, which is 834.95. Okay, so last step here is kind of exciting. If I want to predict the number of new cases is a list 2, okay, which is our y variable, and I want to know when that's 670. This is what I do right here. So I go 670 right here. And I'm going to solve this equation for x. That's what I'm going to solve for right here. So first step, this is now kind of more of an algebra 1, so linear, solving a linear equation. So I'm going to subtract this from both sides. Okay, so that I get negative 16495 equals negative 26.51x. One more step here, just divide by the coefficient here. So divide by negative 26.51. Okay, final. I'm going to write it up here. Give myself some space. I get approximately 6.2221, and that's years since. Estimate the calendar year in number of cases there would reach 670. So the estimation, that's cases since 2003. So the calendar year would be 2003 plus that. So 2009 to 2010. If I want to estimate exactly, I would say it'd be 2009.221. That would be approximately the calendar year. So here we are using these regressions and using it to estimate.